Now, this is a very classical question, so I would like you to pay attention. You can also pause the video to see if you can do it on your own. So let's build it line upon line. Let's read. It says the speed of a boat in still water. Still water means the water is not flowing, the water is just calm. So the speed of a boat in still water is 20 km per hour. At what angle should it be heading in order to travel directly across a river whose current has a speed of 12 km per hour? Now, let's build this question. Now, this man is starting. So, the emphasis on this question is that he wants to head directly across. Please, I'm going to highlight this directly across. So, now let's put a point. Let's say that this man started from this point A and he wants to directly across A is going to be B. So, he wants to move from A to B. That's the first thing you need to note in this question. He wants to get from A to B. But now this river is flowing and you need to know that it's going to affect his journey, because if this river is flowing, now they did not even specify the direction of the flow of the river. So let's just take any direction. Let's say towards the east. So let's say this is a river, and then they're saying that this river is flowing in this direction. So I'm just going to use my, it's flowing in this direction, the river in this direction, right, towards the east. Now this is the river current and it's flowing with a speed of 12 km per hour. So let's represent the speed. Let me use a red color. So the speed of this river is in this direction. So I'm just going to put it here. This is the speed of the river because the river is flowing in that direction and the speed is 12 km per hour. This is the speed of the river. All right. And then this man, the speed of the boat, all right, I'm assuming that a man is riding the boat. The speed of the boat is 20 km per hour. But please, I want you to know something. Do you discover that if this man ignorantly steers this boat in this direction towards the north like this, using another red line, you see that he's not going to arrive at B, because as he's going upward, the river will be pushing him towards the right because that's the speed of the river. So basically, he's going to end somewhere here. You finally see that he's going to end somewhere here, which that's not what he wants to do. He wants to get directly across. So he cannot go straight line from A to B. It's not going to work. So we're going to remove all those lines. He's not going to stay in that direction. Instead, let me use another color for the direction. Let's say that he's going to stay in this direction. He should go a direction like this, something like this. We are not sure. All right. So that as he's moving in this direction, let me call it C. Let me say that he's going to end at C now. As he's going from A to C, but because of the river currents, it's going to push him, you know, ultimately back to B, but it will be at a specific angle, and that's the angle we're asked to find. So we're asked to find that specific angle which he must head his boat, let's call it theta, such that he's going to end at B regardless of the river current. So I'm just taking my time to build this question so you can really understand what's going on. So let's put values there. He's going from A to C now. He has to go in the direction A to C. So the plus the river current, he gets back to B. So what's his speed going from A to C? The speed of the boat is 20 km per hour. So we have 20 km per hour. That's the speed of the boat. But then the river, because basically if you remember from your parallelogram law, if you complete this parallelogram this way, just going to do it rough and I'll clean it again. You see that if this is 12, this place will also be 12 km per hour. Basically, because that's the speed of the river. So we have a right angle triangle now because this is a right angle. Right, so I'm going to draw this triangle out again. So let me just draw this triangle again so we can now begin to work with it. So we have this one going in this direction. The speed of the river is in this direction and he wants to go in this direction. Actually, this is original plan. So let's put the angle. You see that this is 90 degrees. And then going from, let's call this A, B, and C. Right? So going from A to B, the speed is 20. I'm just going to leave the values, the SI units now. But from B to C, that's the speed of the river, which is 12. You know that this part will be the resultant. Of course, yes, because if you combine these two speeds, you're going to have just one speed, which you're taking from A to C ultimately. So that's the resultant. And then this is angle theta. So basically, we have to find this angle theta. So all my struggle is just to explain this in such a way that you can understand it easily. But then we have a challenge. That angle theta now, primarily if you want to solve for theta, This 12 is opposite theta, why 20 is opposite right angle. So we can use sine. We can say that sine theta is equal to opposite, which is 12 over hypotenuse 20. But the question has a twist. It says that the angle the angle is theta, where tan theta. So the question is asking us specifically about tangent of theta, not sine. So we need to work with tangents. Well, let me just write the trig functions. We have so, ka, twa. So we're working with tan. You see that tan is opposite over adjacent, right? So which side is the opposite? Opposite is the side that's opposing the angle. So that's 12. I'm going to highlight it with blue color. So this is the opposite. Now, what's the adjacent? Remember, 20 is not adjacent. 20 is the hypotenuse because it's facing the right angle. So adjacent is actually the resultant. So for us to solve anything, we need to first of all find that resultant. What's the resultant? Well, let's use Pythagoras theorem. So let's make space and solve now. So using Pythagoras theorem says that the hypotenuse squared is equal to opposite squared plus adjacent squared. Now the hypotenuse is 20, so 20 squared is equal to opposite squared, which is 12 squared plus adjacent. Let's just is r, so r squared. Now making r the subject to the formula, we just need to move 12 squared the other side. So we have r squared to be equal to 20 squared plus 12 squared crossing becomes minus 12 squared. So let's just do this. R squared is equal to 20 squared is 20 times 20, which is basically 400, minus 12 times 12 is 144. So R squared is 400 minus 100 is 300. 300 minus 40 is 260. That will be 256. Alright, so 256. So now we have R to be the square root of 256. Square root of 256 is 16. So R is 16. Now we finally found the value of R. So I'm just going to put it there. R is equal to 16. Now, if we're not looking for tan theta, remember that tan theta is opposite, which is 12 over adjacent, which we have now found the value as r. So you know that our tan theta is simply 12, which is opposite, over 16, which is adjacent. So let's solve it there. That will be our final answer. So the question says we should find the tan of the angle. So we're going to say that tan theta, which is opposite over adjacent, is equal to opposite is 12, adjacent is 16. So let's just reduce it. 3 into 12 is 4. No, 3 can't divide 16, so we can't work with 3. Let's work with 4 instead. 4 can divide both 12 and 16. So 4 into 12 is 3, and 4 into 16 is just 4. So tan theta is just 3 over 4, and that's the answer. This question is not too difficult. Why I'm taking my time is just to make everything, try to build it step by step, line upon line, precept upon precept, so that everyone can follow. So that is it for this question.